Equivalent circuits. Equivalent circuits means if two or more resistive elements are connected in series or parallel, what will be the equivalent value or resultant value? So first I am going to take a resistors. Resistors are connected in series. Yeah. Is the whiteboard visible to everyone? Please respond, Amma. So let me take. Okay, thank you. So there is a voltage source V. Voltage source is V. You might have already studied about these things. The two resistors are connected in series. What will be the equivalent resistance? All those things you might have studied. Again, I am going to discuss here. Resistor R1 and R2 are connected in series. When can you say these resistors are connected in series? If the two resistors are connected with a single node, this is known as a side by side or so these two, you can say these elements are connected in series. Technically, I will tell when these two connected are when the two resistors are connected in series means, and if you see the circuit, from which terminal current is delivered. Now switch is closed. From which terminal current is delivered? Is it from positive polarity or negative polarity? Chapandama, if the voltage source is there, which is having plus polarity and minus polarity, please tell me. Please tell me from which polarity the current is going to be delivered.
Positive.
Yeah, positive polarity. Very good. So this is the direction of the current. So current is flowing in the circuit like this, clockwise direction. Okay. So I is flowing through this R1 as well as this R2. So technically, when the two resistors are said to be in series means if the same current, listen carefully, the same current is flowing through the resistors R1 and R2. Or if another resistor R3 is connected, then the same current is flowing through the R3 also. That means the same current is flowing. The same current is flowing through the two resistors. Then these two resistors are said to be in series. Now, then what is the equivalent resistance value of these two resistors when these are connected in series? Now, as these are two connected in side by side, that means same current is flowing. When the different current will flow, suppose, see here, for example, later I will explain by writing the another resistor. For the time being, let us imagine that R1 and R2 are connected in series. Now, let us calculate equivalent resistance between them by using the KVL. By using KVL in this loop. So what is the KVL? Algebraic sum of all voltages around a closed loop equal to 0. Algebraic sum of all voltages around a closed loop equal to 0 is the KVL statement. So this is 1 voltage, and across this resistor R1 also there is a voltage drop, I'm saying this is the V1. For this, should give the polarities plus and minus because current is flowing in this fashion. And here there is a V2. Let me erase this. So this is V1 and this is V2 plus minus. And this is a clockwise direction current notation. Now please tell me the KVL equation. How many voltages are there? Here 3 voltages are there. Current is flowing in this fashion means current is entering initial at minus polarity. So minus V, yeah, plus V1 plus V2 equal to 0. So this is by using the KVL equation. Now from Ohm's law, from Ohm's law, please tell me what is the V1 value in terms of current and current I is flowing and R1 is the resistance. What is the V1 voltage drop across the R1 from the Ohm's law? V1 equal to, please respond. Anyone? What is the V1 value from the Ohm's law? Which current is flowing through the R1? Am I audible?
IR1, sir.
IR1. Very good. I into R1 or R1 into I. And what is the V2? R2 into I. So let us substitute these two V1 and V2 drops in this KVL equation. That implies minus V plus V1 is R1 into I plus V2 is R2 into I, which is equal to 0. So from this equation, I can write R1 plus R2. I can take I as a common. R1 plus R2 into I plus I am writing V RH side V. Okay, na? Is it clear here? So which can be written as V equal to R1 plus R2 into I, which is equal to R equivalent into I. Okay, V equal to R equivalent into I. What is R equivalent here? R equivalent equal to what? Where R equivalent equal to R1 plus R2. Remember this. So when the two resistors are connected in a series, the equivalent resistance is equal to R1 plus R2. Suppose if another resistor is connected here, then what will be the resultant resistance? Then we have to add plus R3 plus R3. Then R equivalent will be R1 plus R2 plus R3. And if n number of resistors are connected, then Rn. This is the formula for n number of resistors are connected in series. So just we will take a summation of the values of resistances. So this is about the resistors which are connected in series. Okay. Now here the important thing is that here the voltage is sharing between V1 and V2. So if you want to calculate V1 and V2 directly, there is some formula will be there that is called a voltage division. Suppose here, suppose there is a 50 volts is there, for example. If there is a 50 volts is there, based on this resistance values, the voltage is going to be share. That means across this R1, V1 may be 20 volts, and across this resistor R2, V2 may be So the equivalent resistance will be R1 plus R2 plus R3 plus on Rn. This is the equivalent resistance when the resistors are connected in a series. Sorry for the disturbance. See here, yeah, R equivalent value equal to R1 plus R2 plus 1 Rn. Now, if the 50 volt source is there, in proportional to this R1 and R2, the volt is going to be share. So across this R2, there may be a 30 volts and there may be a 20 volts. Then how to calculate by using a shortcut formula? There is two formulas which are related to voltage divisions. So we can directly calculate V1 voltage and V2 voltage by using a single formula without writing a KVL equation. Hey, am I audible to everyone, Amma? వినిపిస్తుందా?
Yes, sir.
అర్థమవుతుందా? If anybody having any doubts, please ask me, because we are at the beginning. Try to understand. If I am going fast, you can stop me, and if anybody have any doubts, you can raise your hands, because we are at the beginning. Mathematics are based on these concepts only. These KVL, KCL, Ohm's law, some important formulas are very much required to solve the problem. No theory questions will be given in first unit and second unit. From third, fourth, fifth units will get theory questions, but in first and second units only they will give you problems and we have to solve the problems. Some derivations and problems only they will give. Don't expect the theory questions. If you want to solve the problem, the basics are very much required. Please follow. Now, see, once if you have these formulas, equivalent resistance, I want to calculate V1 value directly. What is the V1? R1 into I. So from this V1 equal to R1 into I, yeah. And from this equation, what is the I here? ఇక్కడ ఈ ఈక్వేషన్ నుంచి నేను I వాల్యూ రాస్తున్నానమ్మా. I ఈక్వల్ టు ఏం రావచ్చు ఇక్కడ నేను? I ఈక్వల్ టు V బై R1 ప్లస్ R2. గుర్తుపెట్టుకోండి ఇది. ఐఎమ్ గోయింగ్ టు రైట్ అనదర్ పేజ్. I equal to V by R1 plus R2. That is one equation. Let me give the equation numbers. This is 1 and this is 2 and this is 3. I'm going to substitute I value in the equation 3, which is equal to V1 equal to R1 into I. V1 equal to R1 into I. What is the I value? Please tell me. I equal to, చెప్పండి, I equal to, please anybody? V by
R.
R కాదు, ఈక్వేషన్ 1 V by R1 ఇక్కడ ఉంది కదమ్మా ఇంతకుముందు ఈక్వేషన్లో. V by
plus R2.
R1 plus R2. Very good. R1 plus R2. Okay, this is V1. So what I'm trying to say is that V1 equal to V into R1 by R1 plus R2. So this is voltage division formula directly without writing KVL and KCL equations. So let us say this is equation number 4. Without writing KVL and KCL equations, we can write the voltage V1 dropped by this across R1. Similarly, we have in equation 3 V2 equal to what? R2 into I. So now R2 into what is the I value? V by R1 plus R2. So which is equal to V2 equal to V into R2 by R1 plus R2. See here, this is equation number 5. If you observe these two equations, see, observe carefully these two equations. These are the voltage division equations. What do you mean by voltage division? I am drawing the same circuit here. If I use the 50 volts here, and there is a resistor R1, a 5 ohm resistor, and there is another resistor is 10 ohm resistor. Simply, if they will ask what is the voltage across 5 ohm resistor and 10 ohm resistor, then what is the procedure we are going to follow? We have to write the KVL and Ohm's law and substitute the value and all those things. Then finally we will get V1 and V2. And without writing KVL and these procedure will be followed in complex circuit. If the circuit is bigger, sometime then we will go for voltage division formula. So these 4 and 5 are voltage division formulas, which are used to calculate direct voltage across 5 ohm and 10 ohm. If I want to calculate voltage drop across 5 ohm, then what will be the V1? V1 equal to V. What is the V? Source voltage. Source voltage is 50. 50 into resistance R1. Same resistance we have to substitute. 5 by R1 plus R2. R1 is what? 5 ohm is R1. 5 plus R2 is 10. So finally, 50 into 5 by 15. So this will be voltage. Okay, na? So directly we can calculate the voltage across this 5 ohm and similarly voltage across 10 ohm also. But here V into total voltage, V into this resistance you have to substitute R2 resist. This is divided by R1 plus R2, 5 plus 10. So in this way we can directly calculate the resistances without applying a KVL, KCL and Ohm's law. These are the direct formulas. So equations 4 and 5 are the what? Voltage division formulas. Voltage division formulas. You have to try to remember. So ఎలా గుర్తుపెట్టుకోవాలమ్మా? V2 equal to total voltage. So this is total voltage అంటారు. Generalized formula is voltage across a particular resistor R is total voltage. That means source voltage. Total voltage into same resistance value. Same resistance అంటే suppose if you want to calculate voltage across this 10 ohm, same resistance by sum of the two resistances value. Sum of the two resistance value. So this is called a voltage division formula. So you will use this voltage division formula later. So this is about the two resistors are connected in series. The equivalent resistance is R1 plus R2 plus. If n number of resistors are connected, R equivalent equal to R1 plus R2 plus R3 and so on up to Rn. And voltage division formulas are V1 equal to V into R1 by R1 plus R2. So how to remember this one? Total voltage means source voltage into same resistance. Same resistance and suppose if you want to calculate voltage drop across 5 ohm resistor, then you have to substitute 5. Okay, na? Suppose if you want to calculate voltage across 10, then you have to multiply with the 10 divided by sum of these two resistances. That is the formula we have to remember while solving the complex problems. So this is about the resistors are connected in series. So if you understand these things, then we will move to parallel. Resistors are connected in parallel. So anybody have any doubts in this? Please respond. దీంట్లో ఏమైనా డౌట్స్ ఉన్నాయా?
No, sir.
Okay. So next, resistors are connected in parallel. Now let us see what is the equivalent. So this is a voltage source V, which will deliver the current I. When the closed path is available, then only current can flow. This is, let us say, R1. This is R2. R1 and R2. So how can you say these two resistors are connected in parallel? So this current is coming from the source as I. So if you see these two resistors are connected at this node, and the two ends of these two resistors are connected to other ends. Then the resistors are connected in parallel. Another thing is that here the psi current is divided into the psi1 current, and this is I2 current. That means the current division is taking place. Between these two resistors. That is the thumb rule to know the resistors are connected in series or parallel. So different currents are flowing through the R1 and R2. Then the resistors are said to be in parallel. చూడండి ఇక్కడ I1 current is flowing and here I2 is current flowing. Current is going to be divided. Then the resistors are connected in parallel. In the previous case, if you say this is R1 and this is R2. Here the same I current is flowing through this R1 as well as R2. Then these two resistors are connected in series. We can say these two resistors are connected in series. But here current is dividing. So these resistors are connected in parallel. Okay. And one more rule is that if the two resistors are connected in parallel across this voltage source, across the parallel branches, the voltage will be same. Across parallel branches, that means this branch, resistor R1 branch, resistor R2 branch, and this voltage source branch. This is active element and these two are passive elements. So this one and this one, all these three elements are connected in parallel. So if any resistor is connected parallel to the particular voltage source, the voltage across that particular resistance is only. That means parallel voltages are same. That means this voltage across this R1 is V, like plus and minus. Here also, so parallel, if the two elements are connected across the any voltage source, the voltage will be same. అంతే కదమ్మా, డైరెక్ట్గా ఈ టెర్మినల్ ఇక్కడ కనెక్ట్ అయింది, డైరెక్ట్గా ఈ టెర్మినల్ ఇక్కడ కనెక్ట్ అయింది. వీటి మధ్య ఏమైనా డివిజన్ ఉందా? వోల్టేజ్ డివిజన్. లెట్ మీ క్లారిఫై ఇన్ డిఫరెంట్ వే. ఇక్కడ ఓన్లీ వన్ రెసిస్టర్ R1 ఉంది, ఇట్స్ ఈక్వల్ టు 5 ohms. ఇక్కడ 20 volts ఉంది. See here, current is flowing through this one. ఇక్కడ వోల్టేజ్ ఎంతో చెప్తారా నాకు? వోల్టేజ్ డ్రాప్ అక్రాస్ దిస్ R1 ఎంతో చెప్తారమ్మా? ఎలా క్యాలిక్యులేట్ చేస్తారు? ఫస్ట్ ఐ కనుక్కుంటారు. ఐ ఈక్వల్ టు ఓన్లీ వన్ రెసిస్టర్ అండ్ వన్ వోల్టేజ్ సోర్స్. I equal to V by R according to Ohm's law, 20 by 5. Current is 4 amperes. Then V equal to ఏంటి? R into I కదా. R value is how much? 5 ohms. Current is 4. So finally ఎంత voltage ఉంటుందమ్మా? 5 into 4, 20 volts. అంటే the voltage across this R1 is how much? 20 volts. What is the source voltage? 20 volts is the source voltage. And across this also 20 volt source. So if this element is connected across this 20 volts, the voltage will be also same. So likewise here also R1 is connected across this voltage source. So the same voltage will be appear across this R1 as well as R2 also, because the same terminals are connected here also. So same voltage appear అవుతుందన్న. అదే సిరీస్లో కనెక్ట్ అయితే వోల్టేజ్ డ్రాప్ ఉంటుంది. అంటే సిరీస్లో సపోజ్ ఇక్కడ ఒక 10 ఓమ్ రెసిస్టర్ కనెక్ట్ చేశాను, ఇక్కడ ఒక 20 ఓమ్ రెసిస్టర్ కనెక్ట్ చేశాను, ఇక్కడ ఒక 50 వోల్ట్ సోర్స్ అంత 100 వోల్ట్ సోర్స్ ఉందనుకోండి. సో బేస్డ్ ఆన్ దీస్ రెసిస్టెన్స్ వాల్యూస్ ద వోల్ట్ ఈస్ గోయింగ్ టు బి షేర్. ఇక్కడ ఒక 20 వోల్ట్స్, ఇక్కడ ఒక 30 వోల్ట్స్ ఉంటుంది. అంటే ఈ రెసిస్టర్ దగ్గరకు వచ్చేసరికి ఏమవుతుంది? వోల్టేజ్ 30నే అవుతుంది. అంటే వోల్టేజ్ అనేది తగ్గిపోతుంది. ఇక్కడ వోల్టేజ్ ఈస్ గోయింగ్ టు బి రిడ్యూసెస్ అక్రాస్ 30. So in practical circuit that should not be happen. That is the reason why all the appliances, electrical appliances are connected in series or parallel. Source కి ఎట్లా కనెక్ట్ చేస్తారమ్మా? సిరీస్లో కనెక్ట్ చేస్తారా, ప్యారలల్లో కనెక్ట్ చేస్తారా? ప్రాక్టికల్ ఎగ్జాంపుల్ ఏంటంటే స్విచ్ బోర్డు ఉంది కదా మన ఇంట్లో, ఫ్యాను, లైట్స్, తర్వాత మిక్చర్స్, ఇవన్నీ ఎట్ ఏ టైం కనెక్ట్ చేశారు అనుకోండి. సిరీస్లో కనెక్ట్ చేస్తే వోల్టేజ్ డ్రాప్ అయ్యి తగ్గుతూ వచ్చేసరికి ఫైనల్ వన్కి తగ్గిపోతూ ఉంటుంది. అదే ప్యారలల్లో కనెక్ట్ చేస్తే ఏమవుతుంది? అర్థమవుతుందా కాన్సెప్ట్? ప్యారలల్లో కనెక్ట్ చేస్తే ఏంటి అడ్వాంటేజ్? వాట్ ఈస్ ద అడ్వాంటేజ్ ఇఫ్ ఆల్ ది అప్లయన్సెస్ ఆర్ కనెక్టెడ్ ప్యారలల్లీ?
No voltage drop.
No voltage. Same voltage will be appears across each and every appliance. If you see appliance rating, there is a 230 volts. For every appliance there is a 230 volts, 230 volts, 230 volts ఉంటుంది. We have to give that much of the voltage. So all the appliances are connected in parallel, so that the source voltage, single phase 230 volts 50 hertz source is applicable across each and every ohm appliance as a 230 volts if you connected parallel. అది ప్రాక్టికల్ సర్క్యూట్ కూడా ప్యారలల్ గానే కనెక్ట్ చేస్తారు. సిరీస్లో కనెక్ట్ చేస్తే మీకు డ్రాప్ ఉంటుంది, దానికి కావాల్సిన వోల్టేజ్ రాదు. సో finally what I'm trying to say is that parallel, if you connect any resistor or any branch or any appliance to the voltage source, the voltage value will be same. That is what I am trying to say, that now okay, now this is entering current here. At this node I am going to write the KCL equation by using KCL at this node 1 or N1. Let us say node N1. Entering current we are taking that as a positive current, and leaving currents are minus current, plus I1 minus I1 minus I2 equal to 0. Once we are if you write 2 or more times a KCL equation, we can directly write I equal to I1 plus I2. అంతే కదా. So from this I equal to, I can write I1 plus I2. Okay na? This is the KCL equation at node 1. Now, as this voltage across this R1 is V, then can you tell me this current I1 here according to Ohm's law? From Ohm's law, I1 equal to V by R1 and I2 equal to same voltage, right? V by R2. So this is equation 1 and this is equation 2. Substitute these I1 and I2 in the equation 1. 1 implies I equal to I1 is V by R1 plus I2 is V by R2. So if I take V as a common here, if I take V as a common, I equal to V into 1 by R1 plus 1 by R2. Okay, na? So now from this V into this is 1 by R1 plus 1 by R2. If I take LCM, R1 plus R2, which is equal to R1 into R2, which is equal to I. Okay. Now from this equation, what I am writing is that V equal to R1 R2 by R1 plus R2 into I, which implies V equal to R equivalent into I. V equal to R equivalent into I. What is the R equivalent here? Where R equivalent is what? R equivalent equal to R1 R2 by R1 plus R2. So this is the equivalent resistance of these two resistors when these are connected in parallel. Or another formula is 1 by R equivalent equal to 1 by R1 plus 1 by R2. This is another formula. 1 by R1 plus 1 by R2 equal to 1 by R equivalent. So the two resistors are connected in parallel. The equivalent resistance is R1 R2 by R1 plus R2, or 1 by R equivalent equal to 1 by R1 plus 1 by R2. Likewise, if a number of resistors are connected, then 1 by R1 plus 1 by R2 plus 1 by Rn up to so on 1 by Rn. Like that we can calculate. So here also, like voltage division in series connected elements, here there is a current division in parallel connected resistors. Suppose this is a 20 amperes current anukundamma. This current is going to be divided through R1 and R2 based on these resistance values. Okay, na? So directly how to calculate without doing all these calculations, what will be the direct formula? That is known as a current division formula. Like voltage division formula in series connected elements, here we are going to discuss about current division formula. For that, we need this equation. V equal to this equation, and as well as these two equations. I require these two equations. I'm going to take this I1 equation, I2 equation, as well as this V equation. Three equations I'm going to take to derive the current division formula. So first equation entama, I1 equal to V by R1, that is one equation. I2 equal to V by R2, that is another equation. And another equation is what? V equal to R1 R2 by R1 plus R2 into I. Okay. Now let us substitute this equation in the above equation. Okay, na? Then I1 implies what is the V value? R1 R2 by R1 plus R2 into I. R1 R2 by R1 plus R2 into I. That is the V value. Okay, divided by what? Chapandama, divided by, this is V value. V value is taking from here, divided by R1. And in numerator R1 is there, in denominator R1 is there. We can cancel out this R1 and this R1. Finally, what is the I1 here? I into R2 by R1 plus R2. This is equation number 4. Okay, na? Similarly, here also. Similarly, here, let us substitute V value in this equation. Then I2 equal to what? R1 R2 by R1 plus R2 into I, total divided by what? R2. This R2 and this R2 will get cancelled out. Then what will be the I2? I into R1 by R1 plus R2. This is equation number 5. So equation 4 and 5 are the current division formulas in parallel circuit. Current division formulas in parallelly connected circuits that are resistors. Okay. Now, how these two formulas are useful while solving the problems directly? Sometimes the current source will be directly given. 10 amperes unnama. 2 ohm resistor is there. Three ohm resistor is there. 10 amperes వస్తుంది. So I want to calculate the current which is flowing through this one and this one. ఎలా క్యాలిక్యులేట్ చేస్తారమ్మా? యాక్చువల్గా అయితే కేసీఆర్లో ఓమ్స్లో అన్ని రాసి చేయాలి. డైరెక్ట్గా ఎలా క్యాలిక్యులేట్ చేస్తారో చెప్తారా నాకు? ఇక్కడ 10 అంటేనేమో టోటల్ కరెంట్ I, R1 అంటేనేమో 2 ఓమ్, R2 అంటేనేమో 3 ఓమ్ రెసిస్టర్. చెప్తారా ఎవరన్నా బై యూజింగ్ దిస్ ఫార్ములా? ప్లీజ్ రెస్పాండ్ ఎనీవన్. What is the I value here? Very good. 10. And R2 means which resistance?
3 ohm.
3 ohm resistor divided by R1 plus R2 అంటే 2 plus 3. Okay na? So 30 by 5. So 5 amperes. So total how many amperes are flowing through this one? 6 amperes flow అవుతుంది. 6 amperes flow అవుతుంది. ఇక్కడ 6 amperes flow అయిపోతుంటే by using the KCL, what may be the other? We can also calculate, but without calculation also you can tell how much current is flowing through this branch. చెప్తారమ్మా? 4 amperes ఉంటుంది. ఎందుకంటే ఇక్కడ 10 amperes అంటే ఇక్కడ 6 ఫ్లో అవుతుందంటే ఇక్కడ 4 కదా, క్యాలిక్యులేట్ చేసినా అలానే వస్తుంది. ఓకేనా? సో ఇన్ దిస్ వే we can use these formulas directly whenever required. ఇక్కడ మీరు కేసీఎల్ రాయాల్సిన అవసరం లేదు, కేవీఎల్ రాయాల్సిన అవసరం లేదు, ఓమ్స్లా కూడా అవసరం లేదు. డైరెక్ట్గా ఈ ఫార్ములాస్ యూజ్ చేసి చేయొచ్చు. ఇన్ కాంప్లెక్స్ సర్క్యూట్ ప్రాబ్లమ్స్ we can use this one because the writing KVL KCL is somewhat lengthy when you use the theorems. So we can use directly the current division formulas, voltage division and current division formulas. And here how to remember these one, ఇక్కడ ఇంకోటి ఆపోజిట్ రెసిస్టెన్స్ వేయాలమ్మా. ఇంతకుముందు సిరీస్ కనెక్టెడ్ ఎలిమెంట్స్లోనేమో సేమ్ రెసిస్టెన్స్ వాల్యూ వేశారు, ఇక్కడ ఆపోజిట్ రెసిస్టెన్స్. సో హౌ టు రిమెంబర్ దిస్ ఫార్ములా? సో కరెంట్ ఇన్ ఏ పర్టికులర్ బ్రాంచ్, సపోజ్ IR1 ఈక్వల్ టు టోటల్ కరెంట్ ఇంటూ which resistance? Suppose if I want to calculate the current flowing through the 2 ohm branch, నేను ఇక్కడ క్యాలిక్యులేట్ చేస్తుంటే 2 ohm బ్రాంచ్ దగ్గర క్యాలిక్యులేట్ చేస్తున్నాం కదా, అప్పుడు ఏ రెసిస్టెన్స్ వేయాలి? ఏ రెసిస్టెన్స్ వేసాము? R2 రెసిస్టెన్స్ వేసాము, అంటే ఆపోజిట్ రెసిస్టెన్స్ అంటారు. ఆపోజిట్ అంటే అదర్ రెసిస్టెన్స్, ఇది 3 ohm వేయాలి. ఆపోజిట్ రెసిస్టెన్స్ బై టోటల్ రెసిస్టెన్స్, ఇలా గుర్తుపెట్టుకోవాలమ్మా. సో IR1 ఈక్వల్ టు ఆర్ కరెంట్, డివిజన్ ఆఫ్ కరెంట్ ఇన్ ఎనీ బ్రాంచ్ ఈక్వల్ టు టోటల్ కరెంట్ ఇంటూ అపోజిట్ రెసిస్టెన్స్. అపోజిట్ రెసిస్టెన్స్ అంటే సపోజ్ ఇఫ్ యూ వాంట్ టు క్యాలిక్యులేట్ కరెంట్ ఫ్లోయింగ్ త్రూ ది 3 ohm అనుకోండి, అప్పుడు ఏ రెసిస్టెన్స్ వేయాలమ్మా? 2 ohm రెసిస్టెన్స్ వేయాలి. అపోజిట్ రెసిస్టెన్స్ బై టోటల్ రెసిస్టెన్స్. సో దిస్ ఈజ్ అబౌట్ current division and voltage division formulas. Okay na? So if anybody having any doubts, you can ask. Once we finish these equivalent resistances, we will do some problems. కొన్ని problems, simple problems చేద్దామండి. Very simple basic problems. ఎగ్జామ్లో ఈక్వలెంట్ రెసిస్టెన్స్ వాల్యూ కనుక్కోమంటారు, దెన్ వీ హ్యావ్ టు క్యాలిక్యులేట్. ఇది ఏవి? 1 ohm, 5 ohm and 4 ohm. My question is, what is the equivalent resistance across AB? చెప్తారా? You have to confirm that these resistors are connected in series or parallel, then you will go for the formulas. All these resistors are connected in series or parallel amma? Cheptara evarana?
Series.
All are connected. How can you confirm these are connected in series? You have to imagine that there is a voltage source undanukondi, actually ga ledu, voltage source undanukondi, ఇక్కడ ఒక 10 volts ఉంటే కరెంట్ ఇట్లా ఫ్లో అవుతుంది కదా. సో సేమ్ కరెంట్ ఈజ్ ఫ్లోయింగ్. ఓకేనా? If the same current is flowing, then we can say these elements are connected in a series. Now, as the same current can flow through all the elements, we can say these elements are connected in series. Then the equivalent resistance will be sum of the resistances, 1 ohm plus 5 ohm plus 4 ohm. What is the total resistance amma? 10 ohm. Okay na? Sometimes these are simple questions. By practice we will get the answers for complex problems. Next, I will give another problem here. What is the equivalent resistance across these A and B? So this is 2 ohm and this is 5 ohm resistance and this is 5 ohm resistance. Please tell me what is the RAB, equivalent resistance seen by these AB terminals. RAB equal to how much? If you see in this circuit clearly, if the current is flowing in this fashion, here I comes here. At this particular point, current is going to be divide or same current? Current is going to be divide. This is I1 current is flowing, this is I2 current is flowing. Then what is the status of these two resistors? 5 ohm is connected in series or parallel with the another 5 ohm?
Parallel.
Yeah, 5 ohm is parallel to another 5 ohm. Okay, na? So what is the equivalent resistance of these 5 and 5, which is equal to 5 into 5 by చెప్పండమ్మా 5 plus 5, 25 by 10, that means 2.5 ohms. So which implies we have to replace this as a single element which is having a 2.5. So you have to redraw the circuit. 2 ohm. So the 5 and 5 are connected in parallel. The equivalent value is 2.5 across AB. Now can you tell me what is the connection between these 2 ohm and 2.5 ohm? 2 ohm is,
4.5.
yeah, 2 ohm is in series with 2.5. Then what is the RAB? 2 plus 2.5, 4.5 ohms. So likewise, you have to calculate the equivalent resistance values. Okay, na? So I will give you some small homework problem. Understood here? Anybody having any doubts, you can ask here. Let me give another problem. Equivalent resistance is the resistance which is seen by these AB terminals. Ikkada R equivalent. This is 20 ohms. This is the 20 ohm resistor. This is the 20 ohm resistor. So what is the RAB? I will give 1 minute of time. Please tell me the answer here. Let us see who will tell the answer first. చేస్తున్నారా బాబు? Sai Kumar?
Yes, sir.
Yeah, are you solving the problem?
Yes, sir. Yes, sir.
Do it fast. Let us see who will give the answer first. Mohan Deepthi doing, ma?
Yes, sir.
Yeah, please try it. Ranjit,
Sure.
చేస్తున్నారా బాబు? Try it and tell me the answer.
Sir, 10 ohms, sir.
Sai Kumar, how much amma?
R1 10 ohms, R2 in the series because the total resistance
Final
at A
answer.
and B 10 ohms, sir.
Across RAB, how much resistance will be available?
RAB 10 ohms.
Very good, amma. Very good. Nice. Anybody got 10 ohms?
Yes, sir. RAB 10 ohms.
Very good. See, let me solve this problem here. See, first you have to calculate this one. These two are connected in parallel. So parallel means నేను డైరెక్ట్గా స్టెప్స్ వైజ్ రాయట్లేదమ్మా, ఇక్కడే వేస్తున్నాను. Parallel means 20 into 20 by 20 plus 20. 20 plus 20. So 400 by 40. That is 10 ohms. So if you redraw the circuit, this will be a 10 ohm and this will be a 10 ohm. A, B, this is 20 ohm and this is 10 ohm and this 10 ohm. And how these two elements are connected here? How these two elements? 10 ohm and 10 ohm. Same current is flowing, amma. Same current is flowing. So 10 ohm and 10 ohm. These are connected in series. Series means 10 plus 10, 20 ohms. If you further redraw the circuit, this will be, this is already a 20 ohm and this is 20 ohm across A and B. And what is the situation of this 20 and this 20? 20 ohm is connected in series or parallel? Current is going to be divided parallel, connected in parallel with the another 20. Again 20 into 20 divided by 20 plus 20, which is equal to 10. So if you redraw the circuit, A, B, 10 ohms. Then what is the RAB here? RAB is how much? 10 ohms. Sorry, ఇదంతా ఎందుకు చేస్తున్నారు అంటే simply they will calculate, they will ask a question like this. They will give a 20 volt source is here. They want to calculate total current IT. ఇక్కడ ఎంత కరెంట్ క్యాలిక్యులేట్ చేయమంటారు. అప్పుడు ఎలా చేస్తారు? సింపుల్. Across these two terminals, if you know resistance, resistance offered by these two terminals, if you know, then directly what is the IT value according to Ohm's law? IT equal to, we know, V by R kada, V by R. So V is 20, R is R equivalent seen by these two terminals. ఎంత రెసిస్టెన్స్ ఉందమ్మా ఇక్కడ నుంచి చూస్తుంటే, అంటే ఇవన్నీ క్యాలిక్యులేట్ చేసిన తర్వాత ఎంత రెసిస్టెన్స్ వస్తుంది ఇక్కడ? How much resistance is offered for this current? Please respond. Equivalent resistance ఎంతమ్మా ఇక్కడ? 10 ohms. So 20 by 10. How much current is flowing? 2 amperes. ఇక్కడ ఎంత కరెంట్ ఫ్లో అవుతుందమ్మా? 2 ampere current is flowing. So in those situations, this R equivalent value is going to be calculated. So to simplify these values, we are calculating the equivalent resistance. What is the equivalent resistance? Equivalent resistance is the resistance which is seen by the target terminals A, B, across A and B. You have to see from this side. Finally, I will give a problem. With this, I will close. So note down this problem. Plus minus 25 volts. See, what is the current IT, total current IT. So how to calculate this total current IT here? For this, I will tell the procedure here. Calculate the resistance between this terminal and this terminal. Let us take this is A and B. So first calculate the RAB seen from this AB. So remove this 25 volts. So current is flowing in this fashion. So these two are connected in parallel, and these two are connected in series, and these are parallel. మొత్తం క్యాలిక్యులేట్ చేసిన తర్వాత RAB కనుక్కోండి. Once if you get RAB equal to some value, then what is the VT? 25 by RAB substitute చేయండి. Then you will get the answer. So this is the advantage of series and parallel connection element resultant R equivalent value. Okay. I stop here. If any